warm welcome to Derrick Vandenberg. He is a specialist in water treatment, 19 years in business, has a Bachelor of Science degree in chemistry, and also Certified Water Treatment Technologist with Association of Water Treatment Technologists. Today's presentation is about filming amines, which is widely used in treatment of chilled water loops as well as heating water loops. So Derrick, please.
All right, thank you, Tim. Thanks for the introduction. This talk will be about film forming amines for any boiler application. May or may not be familiar to you, but the main technology that we're using in Alberta has come to us from work being done in Europe. In the 1970s, filming amines were developed as an alternative to neutralizing amines. And in steam boiler applications, octadecylamine was the main and only film forming amine used at that time. Some people had all right experiences with it. Others ended up with what's colloquially known as gunk balls in their systems. The ODA would form into balls when it was overfed, or maybe some other reasons that made that happen. But gunk balls would end up in the system and cause all sorts of grief. And so ODA had a short period of time in the spotlight, but faded away. In Europe, in 1980, what was considered the first generation of film forming amines was developed in France. It was marketed there. By 1988, what they considered a second generation was being marketed, some major improvements in the product. At that point, that company and the proprietors of that company split, and one company's focus went one way, another went another. That second generation, back 1988, that one company has been sold and bought 4 times. Currently, that product doesn't appear to have changed and is being sold by Carita and 3 other companies around the world. The company that we're working with, Odyssey, in 2020 has developed what they consider their 5th generation of film forming amines, and that's a product we're working with, and that's our experience. That's our experience, and what we bring to the table here in this presentation comes from working with that product. So I will take you through how film forming amines work. Consider film forming amine as a one-shot treatment that coats every single portion of your piping. Once you release it into your system, it aggressively finds its way onto pipes, metal surfaces anywhere. The reason being is that it is hydrophobic and it does not want to be in the water. So it's driven out of the water and finds its way attracted to metal surfaces. And so film forming amine can coat everything, your deaerator, your condensate piping. Think of a painted surface, it's painting everything. So now if we look at inside a pipe, we're going to see the following. We have a sectional view of pipe. We have the pipe surface here. We have oxygen molecules. We have water. Hopefully there's not this much air in your system, but we're going to find out that as we put the filming amine in the system, it will form on the surface of the pipe. That will keep the oxygen from reaching the metal, and therefore, like many corrosion inhibitors, will inhibit the ability of oxygen to corrode metal. Now, in addition to that, there's a Duprat's thesis in that oxygen can still find its way to corrode metal through a porous layer of corrosion products, in that there is nothing, oxygen molecule is not that large that it can't find its way to the metal surface around loose iron. So if you can remove this loose iron, this porous iron that's in a metal pipe, oxygen will no longer be able to reach that. So filming amine offers this, where I talked about it being aggressively finding its way through a system. It offers a cleaning effect. With filming amine added to a system, doesn't matter whether it's a closed loop or a boiler system, you will, a steam boiler system, you will find an increase in the iron content in your water soon after addition, because it is effectively taking porous metal and stripping it from the surface of a pipe and getting down to the good quality metal. A benefit from that is if you're removing product that doesn't need to be there, you should get improved heat transfer. And so at this point, I'd like to show you two videos. Show you a video of the same boiler tube treated with phosphate and hydrazine, and another one with filming amine. So I'm going to hopefully pull up the right one. That's with filming amine. Are you seeing that now?
Yes.
Okay, so this is the boiler tube at 217 psi and a heat being applied to it at 10 kilowatts per meter squared. And you see some boiling action. Now I'll try to pull up the next video with filming amine. Are you seeing that? Good. And so you see much more boiling action with filming amine. That suggests that the heat surface is cleaner, able to transfer heat better. So if I play that first video again, phosphate and hydrazine, and filming amine. So that's what we believe, we expect is happening, that you will get better heat transfer with the filming amine and find yourself with more efficiency in the inside your boilers. So now we'll move on from the cleaning effect to the corrosion inhibition portion of this. I will give one example of this. We are using this in a heating water loop at Aurora Cannabis, which is at the Edmonton Airport. The loop is 4,000 cubic meters or 4 million liters. There's 3 million liters in a thermal storage tank and 1 million liters running throughout the greenhouse. It's been in place for just over 3 years now with filming amine, and the iron and copper levels, which are tested monthly, have slowly creeped downwards, and at this point are under 10 ppb each. I can't test any lower with my hack equipment, but still at under 10 ppb. I don't see that effectively in any other closed loops that I treat. So this filming amine is proving to be an excellent corrosion inhibitor. The coupons that we have are also reflect that corrosion inhibition. Spoke about improved heat transfer being energy efficiency, but there's another aspect of the energy efficiency that this offers, especially when it comes to steam boilers. In your feed water, as you add sulfite and phosphate to them, if you're doing a traditional treatment of sulfite and phosphate, you will find that the sulfite and the phosphate increases the conductivity of your feed water, which limits your cycles of concentration. Let's say if you have a maximum conductivity limit of 5,000 microsiemens, you will get to that point mathematically faster with a higher feed water conductivity. So sulfite and phosphate contribute to that. Filming amine does not, or adds very little conductivity to your feed water. So therefore, you will get more cycles of concentration from your feed water if you're going to achieve the same 5,000 microsiemens conductivity upper limit for your steam boiler. So in doing that, you'll get more cycles of concentration, you will use less, you'll have less for blowdown, and you will use less gas. So you've got an energy efficiency gain by switching to filming amines. In a closed loop, another efficiency gain is that the residual that you're looking for in a closed loop is all of 0.1 to 0.5 ppm. If you compare that to nitrite and moly, you'll see a huge difference. Moly, you're looking at about a minimum of 80 ppm. Nitrite, you're looking at a minimum of about 800 ppm. So if you're going 0.1 to 0.5 ppm, if you drained your water out of your system, you're looking at much less material to reestablish the residual in the water. And the bonus is filming amine, because it films the surface, it isn't lost immediately. There is some stickiness to the filming amine, much like paint on a wall. It will stick around for a while. And so if you were to do work on a closed loop, drop the loop, bring it back up, and check the level, I have found that it's not that far off from what the levels were beforehand. So it takes very little to reestablish the levels. In a steam boiler system, you were looking at one test for filming amine residual in your boiler and in your condensate. You're looking at a few less tests to do. And finally, another cost savings in closed loops is that filming amine is a biostatic product. It doesn't encourage bacterial growth like nitrite might in an affected loop. And also because it coats the surface, it keeps bacteria, makes it harder for bacteria to adhere to a surface and build its colonization of a pipe wall. So in that, filming amine is there first and is aggressive. Bacteria has a hard time lodging itself onto a pipe wall and growing there. Filming amine has low toxicity. It's great if you're dumping to a sewer that you're not, you don't have any metals, you have low conductivity. These are things that help, and also it's being found that it can be used. It's approved for a couple. It's approved for a couple of food process units by CFIA. It's approved in the States of NSF potable treatments. I don't know exactly all the treatments there, but this product is proving to have utility in those food process areas. And finally, the filming amine doesn't contain heavy metals, does meet sewer bylaw regulations, can easily go to the drain. And in good conscience, you can drop a loop and reestablish it quickly after repairs are made. Going to go to a conversation now on water conservation. As I discussed before, these are some real world examples of some European sites that have seen some water savings, some CO2 energy reduction due to higher cycles of concentration. So a district heating cogen plant running at, what is that, about 1500 PSI has found a blowdown reduction of 50%. And that's equivalent savings of about 4,700 tons at about $4 cubed. That's about $16,000 a year, if closer to $20,000 a year. That might cover the cost of the product in that system. At this loose plant running at quite variable pressures of 16 to 46 bars, found a 73% reduction in blowdown and nice water savings. And this food process plant in Stein, running at just about 100 PSI, but probably having a much lower conductivity, maybe more unrefined feed water, probably not RO feed water, has seen a blowdown reduction 88%, savings of 11,000 tons in water, which at $4 a cube is $44,000, probably covers the cost of the chemical used in that site. In steam applications, a few notes about filming amine. Filming amine does need to be replenished in systems where water is lost. And it is not a cheap product. So it's the most effective in systems with medium to high percentage condensate returns. That's not to say that it doesn't work in once through systems, but the cost will be more than likely will be prohibitive. But we have used it in steam generators, and that's a once through system and has been quite successful. I'll explain that a little later. There are CFI registered products available for application with food products. There are no humidification products and no products available for sterilization of medical equipment yet. And then there's only one real caveat with the application of steam filming amine into steam applications. That's with sulfite. Sulfite, being an oxidizer, reacts with the filming amine, and so in a conversion from a steam boiler to a filming amine treatment process, you would let the sulfite level drop to about 0 before you add the filming amines. Filming amine offers some scale prevention. In this image, you can see calcium carbonate, which is nice solid crystal that easily builds on itself and therefore causes ability to create a hard scale. With filming amine in play, that crystal is modified with some dispersant that is put in the filming amine blends. That calcium carbonate can be dispersed and in the blowdown water gotten rid of in a steam boiler application. So what they have found is that up to 20 ppms of total hardness in the makeup water is okay. Now that's pretty high. You'd really like to run your total hardness lower anyhow. But there's some good protection with hardness. And then if you were in a situation where you don't have a softener, can't run a softener due to cost or some other lack of water, you can add a phosphate to the treatment program and offer additional protection against scale. Now, to move on to closed loops. Filming amines can be overlaid in most closed systems. There's just the one caveat with sulfite, again, that you would want the sulfite to be at 0. Nitrates, molybdates, phosphates, any of those systems can be overlaid with filming amine. What you may want to consider is that because filming amine offers very little conductivity contribution, and because the higher the conductivity, the more likely it is to wear on your equipment internally. If you could see taking a flush to take the conductivity down, you would have a long-term benefit by doing so as you switch over to filming amines. The question may be, how much will it take? Consider what I said earlier about filming amines, and it's like painting a surface. If you have a rough, aged pipe wall, there is more surface area. It's going to take more filming amine to do the job. If you have a brand new system that is smooth as could be and clean, it's going to take much less. So filming amine, it's hard to say it's an exact ratio of one to another to say, the system is 10,000 liters, it's going to take this much filming amine. That equation you can throw out the window, because you really, unless you knew your pipe surface was a brand new. We work at about a 1 to 333 ratio, plus or minus a wide variety, depending on where we're working with. Filming amine, it works very well with polyethylene, polypropylene, PVC, EPDM, PTFE, and CSM. There are products you don't want to use it with in the pumping application. We haven't had any issues with materials in a closed loop system, but you really don't want to try to pump filming amine with Viton natural rubber ABS. We have a situation where a customer is buying it by the drum, wants to dispense it into pails, is using a hand pump. It's having a heck of a time trying to find one with the right materials. Now that they've found the one with the right materials, it's working just fine. But it swells Viton natural rubber ABS readily. And so it can make those pumps useless to you. So in the pumping of the chemical feed pumps or transfer pumps, be aware of what chemicals what materials of construction you're using in those products. Now, for a test kit, here's a visualization of the filming amine in play. This suggests there's just a 2-layer filming amine. As it's been studied, it's been learned that it's actually a little deeper than that. Could be up to 3 layers, but generally the first layer is the very most uniform layer. And anything that's extra ends up as what's called a micelle. So that is your residual, and that's what you're looking to test in the water. Because, and as you see it as a cell, why? Because of what I said earlier, filming amine doesn't like being in the polar water. So it's clumping, it's coagulating. So we're looking for that. And so we have a couple of methods to test for it. One is the rose bengal method. I like this one. It's simple. Simply 8 drops of each of 2 reagents, shaking and waiting a couple of minutes. For a building operator, for anyone, it's very simply compared to a color strip. And because the residuals are so low, essentially, if the sample is pink, you've got a residual and you're good. But I like to give a number. We're scientific, we're chemists. And so therefore we use the hack unit and have it calibrated such that we can give you an actual number of what's in the system and monitor it a little more closely. Another method is the methyl orange method. The methyl orange method is a solvent extraction method where you're breaking some solvent into your sample. You're shaking it to create a solvent water layer, and essentially pulling the filming amine into the solvent layer, and then pulling it up, indicating with methyl orange against a color, you might say color wheel, but through this comparator can figure out how much filming amine you have in your system. This is a significantly more expensive test per test with this method than the other one. Feeding filming amine, as I spoke about the fact that the iron level will increase, the typical dosage rate starts at 50%. You will see a spike in iron. As that iron comes down, you can move to your theoretical dose and try to achieve your expected limit of filming amine of 0.1 to 0.5 ppm. Because of this iron release and some of the filming amine tying itself in with that iron, you may often see 0 filming amine until you achieve a breakthrough level, and then your filming amine residual will creep up. So it's patience is required, and yet once it's established, it's very stable. So we've got talked about closed loops and steam boilers. There is work being done and products being offered for cooling towers as well. I am currently working with a product at Owens Corning in their cooling tower system to see how that it's working for me I see some galvanized, they use extremely soft water, and I see it's hard on the galvanizing in their cooling towers. So I'm seeing if the protection offered by filming amine in a blended form of phosphonate for cooling towers is going to provide additional protection. So that's what I'm studying with that one. And I'm just going to go through a couple of slides here that show some applications. This is a list I was given in 2009 about some worldwide applications of filming amine. I understand it's in small print here, but you've got an urban heating water loop of 5,000 meters cubed, taking on 800 meters cubed to soften water every year, that's still being applied there in a smallish chilled water loop, but with seeing temperatures, surface temperatures of 300 degrees Celsius, it's being used in that kind of loop. Then we've got a whole bunch of steam turbines, and the pressures just keep going up and up and up. You see here in the Ukraine, 155 bars. That's over 2,000 psi. And this last one, maybe you recognize the name INEOS. INEOS has a plant at the Joffrey site, just east of Red Deer. So INEOS running at 2,800 psi in with filming amine, at least in the year 2009. I haven't verified any of these further, where they're still running 12 years later. But that was then. Go to closer to home in Alberta. I was the first one to use the product in Canada from Odyssey at 10405 Jasper Avenue. It's an office tower. I put it in the heating water loop. In the first month, I got the level up to the over 1 ppm, and that was in 2017. So just a little over 4 years. Or no, will be 4 years in October. It's still in the right range. I have yet to make an addition to that system in that time. It's that stable. We ran corrosion coupons for the first 2 years. We were very pleased with them, and have moved on from there to like the Aurora greenhouse since May. Well, that's 3 years now. Again, 4 million liters. Edmonton City Center, all the loops there. That's a two city block long mall, and with 2 office towers. And all the heating water and chill water loops are now on filming amine, finding it to be quite stable. Once established, it's taken some time to establish the residual on the heating water loops. Nate has 50-ish closed heating water loops, and now about 10 are sitting on filming amine. They're progressively changing them over as service work and conditions allow for switching. And we progress through this list here. We've got Calgary International Airport, 25 loops representing about 700,000 liters worth of water on filming amine. Cancer Center will be using, in Calgary, it's a building that's going to be constructed, will be using filming amine in all their loops. City of Calgary is converting. Brownlee building an Alberta infrastructure site is using it. EPCOR, it's a semi-open system. They keep taking water on in this system, and yet the filming amine is proving to offer really good protection from corrosion. And here's this steam generator that I said I would talk about. In Lafarge Spy Hill, they were having issues with the pipes that were running underneath the aggregate piles for steam heating. And so as the steam was coming up, the pipes were just deteriorating away, and they would last about 2 years. Last year, not this previous season, the season previous, filming amine was tried on the steam generator, and those pipes look good. They're coated, they're black. They are not deteriorating. So in that system, once through, the pain of losing those pipes to rusting underneath the aggregate piles are now much better thanks to using filming amine. And steam boiler applications, not a lot yet, but I am running it at a plant steam boiler at Owens Corning, and man, I shut the thing down. It was being shut down in the summer, and loaded up with sulfite. And last summer I said, don't do that, just turn it off. And so they turned it off, and in September started the boiler up again. That was turned off at 1st of June. And in September, the boilers were started up again, and not a hint of rust in the water, just as stable as could be. I've got your future reading list here. If you wish to do further studying on all of this, this is all from outside sources. It's all accessible on Google. Every one of these, if you put enough of these keywords in, you'll find that paper that's being referred to here, and you can educate yourself further on, and don't just take it from me. Find your information elsewhere. And that leads me to any questions, and I thank you for the opportunity to speak to you.
Well, thank you very much, Derrick. That was awesome. I do have a few questions.
Yes.
One of them is that is the filming amines intended to take the place of the nitrate or the molybdate that we use in our systems currently? Yeah,
absolutely. Yeah, it's a total swap over. You walk away from nitrite and moly completely.
I know that moly, because it's a heavy metal, has found some disfavor in the industry and looking for good replacements for it. But a lot of our systems in our heating, we have heat exchangers in them as well. And a lot of those, you said it was very aggressive against the nitrite or nitrile type gaskets. And so maybe is there any problems with the heat exchangers that, let's say, the plate heat exchangers? Do we kind of veer away from that, or what can we do to protect ourselves from that?
Our experience to date is we've thrown it in multitudes of chill water loops and not have had any issues. So plate frame heat exchangers being very common in those condos with heat pumps, and have not had any issues. So where I was trying to say, avoid these materials for pumping in the systems themselves, we haven't found an issue yet.
I know, because a lot of those heat exchangers do use nitrile gaskets in them.
Correct.
And another one that we find quite often in our systems, and this is a blowback from the late 80s and early 90s, that Victaulic fittings were part of the heating circulated systems that we use. Now, Victaulic has got, of course, at every joint a gasket that's made out of rubber. Any hazards there that you know of?
Again, none. I think it's the lack of limited contact. Like the filming amine is going to contact just the surface that it's exposed to the water. So if your gasket has this much depth behind it, that the filming amine isn't penetrating through to cause issues just at the surface. But if you imagine two surfaces of rubber or Viton, and they start to swell, and you're expecting something to move one against the other, then the swelling will cause that issue, cause them to grab, and then your pump becomes immobile.
All right, I have one more question. I actually have a few more, but you were kind of running up the flag with your Jasper Avenue and the application that you had in there. And I'm wondering if you could remember what the mils per year corrosion on the coupons were before and after.
No, I would say no. It was a moly treated system. And I would say that they were equivalent, nothing extremely better, nothing to, to say wow, but to say, okay, we've moved from a heavy metal to a all organic product, and we're at least as good on the corrosion coupons.
All right.
And yeah, I can't say I recall the numbers. No.
Okay, yeah, I know, because usually standard mils per year corrosion would be between 3 and 5 mils per year on mild steel, and 0.3 to 0.1 on copper. Would you look to see a significant reduction in that corrosion using the filming amines?
I have seen nitrite loops that were like perfectly treated for 12 months and pull off some absolutely fabulous corrosion coupons. Have I seen corrosion coupons as good as this one loop I'm thinking of with nitrite in it? No. Like the numbers were extremely low. And yet, if I'm going to dump a loop that's got nitrite or filming amine in, and I'm going to say the environmental costs of dumping nitrite, which are now on the city's sewer bylaw limits, would be of concern to me. And there is nothing in our filming amine treatment that suggests you're actually losing out too terribly from switching from a nitrite, like say the best nitrite system that I have seen in my territory, to filming amine. Yeah. It's easy to promote in that there are so many loops out there with poorly treated nitrite and moly that the corrosion limit's going to be higher, and that filming amine in its ability to coat has a longer lasting residual in a system that may be treated and then forgotten. Yeah. If you got a nitrite loop at 800 ppm and it gets forgotten and that nitrite level falls to 600 ppm or less, you will actually find pitting corrosion becomes an issue if you're studying the loop closely. Moly is much more, it's a general corrosion inhibitor. If you're under 80 ppm, you drop to 50 to 40 to 30, you still got some protection. Not as good as that when you're at 80, but it's general, you've still got general protection. Filming amine, if you drop to 0 for a while, you've got the surface is still coated. Yeah. Yeah.
I know that we find pitting in with oxygen, but we oftentimes find carbon dioxide can actually get into the threading and cause erosion there as well. If we have excursions where, every building has times when you dump a load and you don't catch up with it with the chemicals, and carbon dioxide tends to get into the threading. Will the filming amines be as aggressive as to get into those areas as well to protect it from carbon dioxide?
I know one concern, like with threading, the only thing I can think of relative to that is those blooms of chemical you see on nitrite systems, but those are usually severely overtreated nitrite systems. I can't say it's been brought up or that I've studied it or have any knowledge of any issues with filming amine with threading. So yeah, I can't really speak to that.
Usually when I get to
strongly
take a look at a system that has nitrate in it, and we find that oftentimes if the packing is letting go a little bit, you can always tell a nitrate system because it continues to leak as it evaporates. It leaves that chemical behind, and you change packing. And what's the look of the filming amines when they find their way out into the atmosphere?
Filming amine itself in the pail is a white milky substance.
Oh, okay.
When I have taken samples and left water on the floor, which maybe I shouldn't admit, but I see nothing.
Oh, good. Well, that's always nice. I'm kind of hogging all the questions. Tim, have you got anything there to add?
Actually, I don't have too many questions. Is that what we've noticed in our application? And we need to be patient and wait for the residual levels of filming amines to establish, and also to be ready to change sidearm filters very often, and perhaps start with 20 plus microns initially, and then slowly go to 10 microns. But that would be, that change will happen very often, that just to be aware.
Derrick, I want to thank you for the time sharing us the information. It's an eye opener, and I expect that we will hear more from you in the future.
Well, thank you. Thank you for the opportunity to present to you. It's the very first time I've done this, and so I enjoyed it.